Alright, so here we are looking at another kind of test within contingency tables, test for homogeneity. And this can, if you look at it closely, can be thought of as a generalization of the test for two population proportions. And let me motivate things again with an example. This is from Dr. Henderson, again a statistician at SFA. And in this example here, what we have is we're wanting to see if there's if the preference of energy policy is related to an individual states of residence. You would think it would be, but let's see if we can test this in a formal way. And so in order to address this question, there were 3 samples that were taken, and in particular the states were subdivided according to 3 categories: oil and gas, coal, so oil and gas, coal, and other. And then a sample of size 200 was taken from oil and gas states, a sample of size 200 was taken from coal states, and sample of size 400 was taken from other states. All right, and so this is different than the let me back up. So we had 200 in the oil and gas state, and out of that sample of 250 said, their preference was to conserve, to emphasize conservation. 56 said emphasize solar energy. 88 said emphasize domestic exploration, and so forth. So you can see those values would add up to the 200 there. What's different here is that we have fixed the sample size per individual population that we are studying. So overall we're studying 3 populations: coal states, oil and gas states, and other states. And we have fixed the size of the sample according to those 3 categories and with respect to those 3 populations, and then counted the number of occurrences for conserve, U.S. explore, solar emphasize, and so forth. And this is different than the skin severity versus age, because in that example, a patient came in and they were classified according to both variables, and so there was no fixing of the variables. We didn't restrict ourselves to looking at 200 people of age category 1, 300 people of age category 2, and so forth. We just observed the 2 categorical variables as they came in. And so that's a difference. And so what we're doing here actually is there's underlying population proportions for each of these states, and we're wanting to compare those sets of proportions. Is the proportion set for the oil and gas states the same as the proportion set for coal states, same as the proportion set for the other states? And that's the kind of hypothesis that we want to look at. I'm going to give some notation to this contingency table. So N11 would be 50, what would this be? N12 would be 88, and so forth. Now in the background there is a population proportion pi 11 that is generating the counts associated with this cell, and in the background there's a population proportion called pi 12 that is generating the counts 88, and here we have pi 13, pi 14, pi 15. Okay, and notice the first subscript denotes the state that we're from, the type of state. For the coal row, there's a pi 21 that's generating the counts 59, and there's a pi 22 that's generating the count 20. There's a pi 23, a pi 24, and a pi 25. Okay, now for the last row here, the other states, there is a pi 3-1 that is generating that count. There's a probability 3-2 or a proportion 3-2 that's generating the 40 count, and so forth. Pi 3-3, pi 3-4, then pi 3-5. And so I want you to be aware of is there's these underlying population proportions for each of these cell counts, and we are interested basically in testing are these three the same, and these three, and these three, and these three, and these three. So we're testing the equality of those sets of proportions. Okay, let me so that's setting up this sort of problem. All right, test of homogeneity. So what we do here is we assume that we have in general R independent samples from multinomial distributions, with each multinomial distribution having C classes. And so for this example here, we're assuming that we have R equal to 3 samples from multinomial distributions, and that those samples are independent of each other. Okay, and that within each sample, what we're observing on each sample is a multinomial count, or multinomial count. In other words, 50 people out of the sample 1, 50 people chose conserve, 88 chose US Explorer, and 56 chose Solar, and so forth. C here is the number of classes and for the multinomial distribution, and there's 5 classes for each of the multinomial distributions. And specifically, we're testing there's 3 multinomial distributions that are represented by these 3 row counts. Can we conclude that those distributions are different? All right, so the null hypothesis, technically looks like this: pi 1j, pi 2j is equal to pi rj. That's true across all the classes. Okay, so that's the same thing as saying here that pi 1-1, pi 2-1, and pi 3-1 are the same. Pi 1-2, pi 2-2, pi 3-2 are the same, and so forth. All right, so that's the null hypothesis. The alternative is that the row distributions are different, that these multinomial distributions are different. Okay, there's some difference in the proportions there. The test statistic for this particular test is under the hypothesis of homogeneity, that is, that the row distributions are the same. The jth relative frequency in any row, which would be Eij over that row total, should be the same for all rows. And hence, each Eij over Ri would be equal to its marginal column frequency Cj over n. So we would have then Eij over Ri would equal Cj over n. And that would imply that the Eij, or the expected count, should be Ri times Cj over n. All right. And so if you look at this expected count, that expected count is the same as what we had in the test for independence. And in fact, when you go further and you look at the overall test statistic that we're using here, the structure is the same as it was for independence. Okay, so are these the same tests? No, they're not the same tests. The hypotheses are different, but the statistic that's used to test the 2 different kinds of hypotheses is the same. This test statistic again follows a chi-square distribution with these degrees of freedom, and with r-1 times c-1 degrees of freedom, and has a large sample size there. Okay, a rule of thumb for large again is that the expected count is more than 5. Now, here is a picture of that contingency table, And if you want to think of this pictorially, we're asking the question, across this distribution, this distribution, this distribution, are the heights of those bars statistically significant? Clearly they're different in the sample, but would they be different for the underlying populations that produced those samples? That's what we're testing here. Okay. All right, and that's a nice picture for us to look at. So we're asking the question, is there sufficient statistical evidence to conclude that preference distributions are different across oil and gas states, coal states, and other states? All right. So I want us to first think about the hypotheses here, just so we're clear on what that would be. In this setting, that would be that pi 1, 1 is equal to pi 1, 2. I'm sorry, is equal to, I got that backwards. Is equal to pi 2, 1 is equal to pi 3, 1. Okay, that is the proportion of coal states that prefer conserve is the same as the proportion of this would be the proportion of oil and gas states that prefer conserve. Is that the same as the proportion of coal states that prefer conserve, which is the same as the proportion of other states that prefer conserve? And so you set that equality up, and then you also have all the way down to pi 1, 5, because there was 5 classes. Is pi 1, 5 equal to pi 2, 5 equal to pi 3, 5? And really what's going on here is we have five sets of equalities. Okay, 5 sets of equalities. You can think of the hypothesis that way. If you want to think of it as another way here, you can think of it as this way, that the proportion of oil and gas states, and I'm going to put a comma J to allow me to look at the jth class, is the same as the proportion for the coal states at the jth class is the same as the proportion for other states at the jth class. And this is for all the J, where J goes through all the classes here: conserve, explore, all the way up to the 5th class of coal. So that's technically what the hypotheses are, but it's checking to see, is there a difference in the row distributions for these 3 kinds of states. Okay, so that's our hypothesis. We have a test statistic, the chi-square test statistic, and here's our chi-square test statistic. If you look in this table, the work has been done for us. These are our observed counts. Here's our expected counts, and this is the contribution to the chi-square test statistic. You do that for each of those cells. So in this case, I had 15 cells in my original contingency table, so there's 15 corresponding expected counts. And so I would add up these 15 numbers here on this last column to get my chi-squared observed. So there's a little work in here, but you can see that it's 289.223. You can verify that. So that's my observed chi-squared value. And if you want to compare this to, if you want to look up in your chi-squared table, so hopefully we've done this enough, you can see that the p-value associated with this chi-squared quantity is really, really small. It's much smaller than 0.01. And so we would reject the notion that the preference distributions are the same. So what we would have here is we have sufficient statistical evidence to conclude that the preference distributions are different across the three types of states. Okay, so that's the word 3 there. And when you look at the sample data, that's not too surprising. You know, the greens are somewhat close across the 3 states, but there's a big difference in the browns there, and then clearly the coal states have a preference for coal policy. So this is a formal test that checks to see, is this difference just a result of variability in the samples, or is it a consequence of something deeper about differences between these 3 types of states? And so the evidence suggests that the preference distribution really is different across the 3 types of states. Okay, this wraps up test for homogeneity. Here on this last page, I've kind of spoken to the differences between homogeneity and independence. You'll want to read this again, make sure you understand that they have the same test statistic, but the null hypotheses are different, and the way the samples are generated and contingency tables are generated are different. So just be aware of that. Okay, that is our module on categorical data.